When you guys came in on your seats, you may have noticed that half sheet of paper, either blue or red. What we're actually going to do is we're going to start off a little differently. We're going to start off with a little bit of an experiment. This is how I start my Algebra 1 course off every single year with my students. And the only task that I like for you guys to do during this experiment is you should see a string of letters. And what I'd like for you to try to do is to make a word from the English language out of those letters. Right? And while you guys try those three, I will tell you a little bit about my Algebra 1 experience. So being an Algebra 1 teacher, I get to see students who have seen or experienced algebra in a plethora of ways. Their teachers from middle school have explained it differently than I will or than I would. They've been assessed differently. They've done different tasks. And from this, they have a different understanding of mathematics from the person sitting next to them. And because of that, I have a little bit of a challenge. I have to try to bring everybody together so that we can talk about it and have one cohesive conversation using language that everybody is familiar with. And so to start off the year, I asked them to do this experiment to try to experience some of the difficulties that other students that they may be sitting next to might be experiencing. So I structure this a little differently with my students. They get a little more time. I'm going to have to unfortunately rush you. The fourth word that you guys are going to have is the one that's on the screen right now. And one hint is that air mace is not an actual word in English. So as you try to scramble it, this last thing that students come in with is something that I find the most difficulty with, and that's their confidence level. Students come in either having succeeded immensely in math, and so they feel really confident about what they're able to do, or unfortunately they've had fatal failures where they don't really think that they can do the math, or they don't really want to try any type of challenge that's being faced in front of them. And so the reason why we actually go through this experiment, just to skip to the results, the blue team and the red team, the reason why we go through this is because I want to illustrate to my students how confidence really plays into their ability to succeed in my class. So we'll go through it line by line, and if you have a word, just shout it out. So the blue team. Map, all right? Map works, or PAM works, or AMP works, all right? Red team. You got to use all the letters. I'm sorry. Did I leave that out? No. You might be hard pressed to find that in an English dictionary. So then, okay, I'm sorry. Let's go into the blue team. Cat, that's right, all right? Cat or tack or anything along those lines. Red team. I hope you guys aren't giving up. The third one. Hey, or pot or opt. Kids are, the blue team's feeling pretty good. And then finally the red team. Nothing. Now, the kids don't know this, but you guys know this. The last word is the same. And the reason why we go through this is because going into that fourth word, a lot of the times, the students from the blue team, they feel like they're going to be able to scramble it. Versus the students from the red team, they automatically just feel defeated. They're really not sure if they can scramble it or if they could have scrambled any of the three words before. And they just don't even know if they want to try. Did anybody actually get that last one? Hey, my students never get it. Yeah, that's right. It's America. When someone first showed this to me, I thought, yeah, I didn't know what to think. I just thought I was really dumb because I didn't get that. Yeah, it's America. And when students realize that, they're like, oh, well, that was obvious. And leading into this, if you were on the blue team, you feel like you can do this. However, on the red team, if you're coming into the classroom not really with that level of confidence, or not really buying into what we're going to be doing, like we're going to be working on really important math that I want you to be able to learn from, and that I want you to be able to teach everybody else around you. But for you to be able to do that, you really have to show that you're confident about everything that we're going to do. So if from what you've done in the past, you do feel apprehensive, or you do feel skeptical, or if you're just unsure of yourself, I don't know that because I'm your new teacher. So please just leave that outside the classroom, and when you come in, just come in with a positive attitude. So like in most algebra classes, towards the beginning of the year, we start off with solving equations. And so this is an equation the student solved, and after they get an answer, they'll probably call me and be like, is the answer x equals 5? And I go up to the student and I'm like, great job, student. Why don't you go on to number 4? And the student says, thanks, Mr. Parmar, sure thing. Now, in my interactions with the students, what I'm doing is I'm essentially training them, almost like Pavlov trained his dogs, in what I say, what my facial expressions are, and what words come out of my mouth are going to lead them in a certain direction. So after equations, usually people go to inequalities, and I explain inequalities as being very similar to equations, except for one rule that we all know, that whenever you multiply or divide by a negative number, you got to flip the direction of the inequality symbol. So a student asks me, is the answer n is greater than 7? And immediately I look at this, I start to scan down, and I see what's at the bottom. Now, I feel like, as a new teacher, a deer in headlights, because I'm not sure how to react. Do I immediately tell the kid that he or she is wrong? Do I tell the student that, hey, go and look back at your steps? Or is there some other thing that I can tell my student so that they realize what their what their mistake was? Because how I react in that moment is, like I said before, going to start to train them in realizing what they should build confidence in. Are they going to build confidence in my ability to confirm their answers? Are they going to build confidence in their ability to follow steps? Or can I give them some type of mathematically logical structure that will allow them to be able to decide upon themselves if the answer that they arrived at is correct or not? So with this in mind, I put my teacher thinking cap on, and I thought about what I wanted to do. For my students, I know that when it comes to math and the units that we've done, they think of it as different islands of knowledge, isolated pieces of information that don't really connect to each other. So what I wanted to do was try to build a bridge between all of those islands. And I wanted to be able to give them a tool, not tools, but a tool that could potentially be extended outside of my Algebra 1 room. Because for something to truly be powerful within mathematics, it shouldn't only be useful in my classroom, but they should be able to use it in geometry, and maybe in Algebra 2, maybe in calculus, and maybe even potentially in college. However, these were things that I wanted, and I really needed to take into account what my stakeholders wanted and what my students would appreciate. They'd appreciate something short, maybe something of 140 characters, and they'd appreciate something that can probably be explained in about 10 seconds, all right? They didn't want a phrase or a tool that was wrapped in dense mathematical vocabulary, but they wanted to be able to look at something and easily be able to understand it so that they could then go and use it. So what did this look like? Well, instead of phrasing things as problems, what I started to do was to phrase the problems that we looked at in the past as mathematical statements. And by mathematical statement, we just talked about it being something that implied some type of relationship. And at this point in the year, we've done equations, we've done linear functions, we've looked at inequalities, and we're now starting to dive into systems. So I felt like this was a perfect opportunity to do a little reflection and to look back at what we've done and to kind of forecast what we might be doing in the future. So what did we do with these 4 types of mathematical statements? Well, first, we went to identify. We took a look at each of the symbols that were in each of these statements and tried to really look at what these symbols meant and how they related to one another. We took a look at then the variables, how many variables were in each statement, and then also we took a look at how many statements there were, a single equation versus a system. We took a look at then the solutions from each type of statement. Is it a point? Is it a series of points? Is it just a single value? Or is it a range of values? And then how, from what we identified and from the solutions that we were able to describe, what did it look like visually? Could we graph it on a number line? Was it something that we were graphing on a coordinate plane? Now, for the students, what this looked like were these 6 questions. And these 6 questions were identical for each type because this then allowed us to be able to easily compare and contrast. If something was no for one type, maybe it was yes for another. Now, these questions went through the identification, the analysis of the solution, and the visual representation. But the most important part was at the end. And that's when I asked them to be able to take our solution and plug it back into the original mathematical statement, because that was really the bridge that I wanted them to see between each of the units that they thought were isolated islands. Now, after going through these 6 questions, as a conclusion, what they were asked to do was they were asked to just come up with that tool or come up with that statement that they could then extend to maybe other units or other courses. So this is an example of what the students came up with. They made a poster with everything that they had found, and we'll just zoom in on type number 3, where we can see that the students, they were able to solve it. They talked about the inequality. They told me it was a range of solutions. They gave me a number line. But this last part was the most important part, because that's where we were really able to talk about what it meant for something to be equal, what it meant, what the inequality symbol meant, and from those connections, they could build whatever tool that I was asking for them to come up with. So how did solutions affect mathematical statements for us? Well, what my students were able to find was, instead of looking for the right or the wrong answer, we now looked in terms of what was true or what was false. And this idea of truth is something that's, I feel like, ubiquitous throughout all subjects, not just mathematics. If you take a look at a science course, they're looking to be able to collect data so that they can explain what's going on in nature, what truly lies behind the principles that we live by. If we take a look at English, they're trying to explain what the true human experience is through the words that they put down on a piece of paper. And in history, they're trying to explain the truth behind why certain events in history occurred. And so by bringing out truth in the math that they're doing, we're able to talk about the solutions. We're able to talk about the symbols that they see on a regular basis, but also we're able to talk about what sometimes isn't true. And so when it comes to the solutions, my students are no longer looking specifically to me for the answer. They're no longer looking at their steps for the answer, but instead, they're able to logically think through whatever the solution is, and that's where, for them, their confidence really lies, finding the truth in the solutions that they come up with. Thank you.